In education, we are always pushing children to think critically, critical thinking. But we need to ask ourselves, what is it? To really understand it, we need a quick etymology lesson. The word critical derives from two Greek roots. Kritikos, meaning discerning judgment, and criterion, meaning standards. So taking a look at it like that, we can give a simple definition of critical thinking as discerning judgment based on standards. So, within technology education, we have a way to do this. We call it our design brief. With our design brief, we give students a lot of background information about a problem that they will be trying to solve. In this case, our robotic arm project. So for this project, students have to create a robotic arm that is powered by syringes, and it has to have at least 60 degrees of rotation, and it has to have an up and down movement, and pick up rods and place them in a containment vessel. And this is the testing surface that the students are provided. For this project, they need to pick up these rods, raise them up, move it to the first cup, dump it in the chemical bath, and then move it from there into the containment vessel. In order to complete this project, they're given a variety of materials. They have a 12-inch by 12-inch sheet of 1/4 inch plywood or Luan, a 3/4 inch by 6-inch by 8-inch board, approximately 1 foot of a 3/16 inch dowel rod, 3 straws, 4 feet of tubing, 6 syringes, and 1 magnet. But how do you create a robotic arm out of this? For our students, the question becomes, what is the right answer? And we have a very important lesson to teach the students here. There isn't one. There are no one right answer for a question like this. But there are thousands of correct answers. So then it's a question of, which is the best answer? So we have to think critically. How can I complete this goal? Using these materials and having access to these tools and these machines. So, quick random question of the day. Did you put on a shirt this morning? Now, I've been told as a teacher that we're supposed to give students some wait time to allow them to think about the question and have a chance to answer it. So, this is your wait time. Have you thought about it? Did you put on a shirt this morning? You did? Good job. If we've ever seen little kids trying to put on a shirt, we know that this can actually be a difficult task. For us as adults, it seems pretty simple, but we have to learn the procedure in order to do this. Criterios and criterion. Even something as simple as putting on a shirt is an example of critical thinking. And this is where in technology education we use the engineering design process. The engineering design process is split up into several different steps to help students push themselves towards critical thinking. We use this as a tool. It is designed to help you solve problems. So, as an example of this, several years ago, we had water dripping from the ceiling of our house and had to figure out, well, why is this happening? We could call in a repairman, could call in a contractor to figure it out, and that would cost a lot of money. We didn't want to spend a lot of money. So I crawled up into the attic and I looked at the HVAC system and found this thing. I had no clue what this was, but it was filled with water and there's water coming over the edge of it. So that's where I started using my tools. Google. Let's try to figure out what's going on. Started looking at do-it-yourself sites. Figured out what the issue was, go to YouTube, find a video on how to replace it. Then I went and found a site where I could actually purchase one. So if you think about hiring a contractor to do this, you're probably looking at a decent amount of money. Overall, we ended up spending about $70 to replace this part. And then there was no more water leaking. This is essentially the engineering design process. Step-by-step sequential process in order to build critical thinking to allow you to solve problems. So this goes back to kritikos, discerning judgment, and criterion, what are the standards. So in order to teach the engineering design process, we have a systematic approach to help develop these students' critical thinking ability. We use Google Documents. It's broken down into the steps of the engineering design process, so that way it's chunked to allow them to work through the process themselves. We start off with defining the problem. Students have to figure out what exactly is the problem that they are trying to solve. Then they look at trying to brainstorm and research ideas. So they brainstorm some ideas of how they can use those various materials shown to you earlier, come up with some quick sketches, put those directly into the Google document to show their work. Then it is time for them to actually try to research things, because one of the big things that we like to try to teach the students is you have a wealth of information out there. Use it. The one thing that we always like to point out, though, is that Google Images is not considered a source. Once they have actually done some research, it is time for them to look at the criteria and constraints. What are those guidelines? What are the limitations for the design brief that we have given them? This goes back to criterion. And at that point in time, they start to actually analyze their ideas that they developed during brainstorming. How well do they meet these different criteria and constraints? And at the end of this, they get a chance to choose what is the best choice. And this is the kritikos, discerning judgment. So at this point in time, they've taken a look at these materials and how to actually use them. And now they are ready to actually generate a solution. They come up with a written design proposal and a final technical drawing. From there, they start to actually utilize the materials, manipulate them, make changes to them in order to try to solve the problem. And throughout this process, they are constantly testing their creation, analyzing it, evaluating it, making changes based on what they see. They also record each day what they've accomplished so that they can see their progress as they complete the project. They take a look at what tests they performed, what were the results, what type of refinements that they need to make. This is critical thinking. They're evaluating what they're seeing and making changes to their product in order to better solve the problem at hand. And this once again goes back to looking at those standards, criterion, and also discerning judgment, kritikos. And eventually they get to the point where they're ready for final testing. Now for this project, the students had a 5-minute limit to move 4 of these different nuclear fuel rods from one cup to the next, go back, pick up another one. So is every project successful? No. Every project is not successful. Usually for this project, we only have about 60% success rate. Is that okay? Absolutely. This is the engineering design process. As you can see, it is circular in nature. If you get back to the part of test, present solution, steps 6 and 7, and it doesn't work, you have a chance to redesign. And you start back over. Identify the new problem, research again, brainstorm again, get to the point where you could construct it again, and try again. You go in circles with it. And there's a lot that you can learn from failure. Thomas Edison said, "I have not failed. I have just found 10,000 ways that won't work." Henry Ford said, "Failure is simply the opportunity to try again, this time more intelligently." And Michael Jordan said, "I failed over and over again, and that's why I succeed." Each step of the engineering design process is broken down. At the end, they write a written reflection. This is really where the critical thinking comes in. Some of the best written reflections are usually from groups that do not succeed in the actual test, because they really sit down and look at their creation, they analyze it, they evaluate it, they try to figure out what did actually work, what didn't work, how they could make changes to it if they had more time, if they got brand new materials, what they could do differently. So while the engineering design process is typically thought of as a method for engineers, it's really just a method to use to solve problems. Like how to put on a shirt. It's backwards. I need to reevaluate. How to tie your shoes. Cooking dinner. Or even going as far as, I need to replace the brakes on my car. Or, once again, trying to replace this thing that you had no clue what it was before. It's a condensate pump. Anyone can use the engineer and design process. It is meant to promote critical thinking. The beauty of the engineer and design process is that it promotes critical thinking. So the next time you have a problem that needs to be solved, think critically. Use the engineer and design process.